Woohoo! We are live. This is Math 60, Intermediate Algebra. We are in section 3.6. There we go. And this is all about word problems. Woohoo! Yay! And we're up to number 5. And number 5 is a slight change. So numbers 1 through 4 were all kind of mixture type problems. And now number 5 is different. So let's look at number 5. How is it different? What do we do? Should we just run around the room screaming? I don't know. Let's see. A boat travels 8 miles down a river in 40 minutes and makes the return trip in an hour. Calculate the speed of the boat in still water along with the speed of the current. Okay, oh my gosh, so many things. So the first thing that I see is I see the word speed. I see miles, I see minutes. And so immediately I'm thinking of the formula distance equals rate times time. We're going to have a lot of these in math because, well, to be honest, a lot of calculations and a lot of math were designed to track the stars and the planets and figure out where everything was going and when it was going. And that's this basic formula. So this is all over math. So it's really important to understand it. So I've got that, but then I've got some weird words like still water. What was it before? So still water means not moving. So if water is moving, and this is a river, so rivers generally are moving and they generally are considered to be moving downhill, right? Water flows downhill. So usually in a river, there is a current and the current goes in one direction for the most part. So when we talk about still water, that's how fast the boat goes just by itself. So if there's a current, that's going to change how fast it looks like the boat is moving. So if I've got a river, this is my beautiful river. This calls for some coloring. There's my river. Ooh, beautiful, beautiful river. Okay, that's a very exciting river. It's in a storm or something. And in the river, if the current is moving this way, let's call the current moving this way, then this is considered, if we move in this direction, this is downstream. And if we go the other direction, that's upstream. And that's where we get the words down a river, and the return trip would be back up. So with the current is downstream, against the current is upstream. Okay, so if I draw a picture of my boat, that's my lovely boat right there. And let's say that my boat is able to, in still water, the boat travels R, and then I'm looking here and I've got miles and minutes. So I've got to make a decision. I've got miles and minutes and hours. I'm going to do R, measure that in miles per hour, which we may run into problems because I'm going to have to translate this to minutes, but I'm going to put that off. That is not the circus I have to deal with right now. Right now, I'm just thinking through the actual setup for the problem. So in still water, the boat travels R miles per hour. Now, it didn't tell me that, but I'm just going to go ahead and give it a letter, and I choose R, and you guys could choose B for boat. I think I was thinking of R because of the river. Or R for rate, a lot of different letters you can use. And then I'm going to put the boat into the water. There's my river. Here's my boat. And so now I need to know the current. The water or the current travels C miles per hour. And again, you can choose whatever letter you'd like. You can use X and Y if you want. And so when the boat is traveling with the current, you actually just add the speeds, the boat speed plus the current speed. Believe it or not, it's just that simple. And I remember the first time I saw that, I was like, no, really? And the answer is yeah, they just add up. So you don't have to worry about any, like weird mix. They just add together perfectly. When the boat tries to travel against the current, though, it goes R minus C. So this is a very important thing to know about the situation with the boat and the river and all that. Now, when you're doing this problem, you are allowed to just assume these two. So you don't have to write all this out. I would encourage you to write the formula, but you don't have to write all of this explanation, because I will understand that you understand this. I just wanted to write it out so you'd have the notes. Okay, so I've got this set up, and then what other things do I know? I know that the river's actually, the whole distance in this problem is 8 miles. And I know that traveling down takes 40 minutes. And then since I've either smartly or foolishly put it in terms of hours, I'm going to go ahead and convert this to hours. So 40 minutes is 40 out of 60 minutes, 40 over 60 hours. And that translates to 2/3 of an hour. Sorry, it got a little squashy down there. So 40 minutes is 2/3 of an hour. So I've converted it so these two agree, the hours agree. If you don't want to deal with fractions, which I can totally see you saying, oh, blah, 2/3, that's a nasty fraction. It's like, that's fine. Then you would have to change the current into miles per minute. And then that would be its own sort of dealio. And there are hard things and easy things, aspects to each of them. Okay, I'm grabbing some more paper. So what do we do with the distance, rate, time problem? Well, it's not a complete deviation from what we're doing in this section. In this section, we are using systems of equations to model word problems. And we can, just like we did before, put together kind of a mixture problem situation, except this one is slightly different. There are actually only, oh no, I'm running out of ink. There are only 2 more rows. So there's the title row and then 2 other rows. I don't need a mixture row down here. I'm going to break this problem down into 2 separate situations. The first one is a boat travels 8 miles down a river. I'm going to go down a river, and then I'm going to go back up the river. Okay. Then I have to figure out what I'm going to keep track of. And I do have this formula, and you'll remember in the past we flipped the formula around, which I'm going to do again. So I'm going to go ahead and put my rate here, my speed, and then I'm going to put my time. And rate times time equals distance. So if distance equals rate times time, then rate times time equals distance. When I used to teach down south in Los Angeles, there was something called the RTD, and that's how people remembered this formula. I want to say it's the Regional Transit District. It was their bus system. So if you happen to be from LA, you'd be like, oh yeah, I can remember that. Okay, so I've got my rate, I've got my time, I've got my distance, I've set up my chart. Let me start collecting information. Now, the really interesting thing about this is we actually know what the distance is. Where it says a boat travels 8 miles down a river and makes the return trip in an hour, that means this is 8 miles. And the trip back up is 8 miles. So the interesting thing is we know the answer. So we're going to have to figure out this part. Now, we know how long it takes to get down the river right here. 8 miles down the river in 40 minutes. So that's this part. So that's 40 minutes, which on the previous page, we had said, oh, but that's converted to 2/3 of an hour. And this is our first example, at least in this section, of having to make sure all the units agree. So everything in this chart is either going to have to be hours or miles or something related. That's the green one. And then makes the return trip in an hour. That's going to be this information right there. So this will be 1 hour. And then we need to know the rate going down and up. And it says nothing else. There are no other numbers. So let's come down to my little cute drawing of my little boat. And I reminded you, or I told you, depending on your perspective, that when you're going down the river with the current, your rate is R plus C. And that going back up against the current, your rate is R minus C. It makes sense. You would go more slowly. Now, what are the units on these? If I just write R plus C and R minus C, I don't have units. They have to be miles an hour friendly. And in fact, it's miles per hour. Miles per hour for the rate. A rate is always going to be this per situation. You always have a fractional situation. Miles per hour, feet per second, something like that. Okay, I think we've got enough of a chart. Now let's go ahead and see if we can come up with some equations. Now we do have the multiplication here, but the addition is not going to work. You can't add rates. You can't, in this situation, you can't add times, and adding the distances just gets us to 16. So we're going to have to be more creative about our formulas. But we can use the fact that this equation, rate times time equals distance, would give us R plus C. Oops. What was that? Sometimes my brain hears C and thinks something else. That's exciting. R plus C times 2/3 equals 8. What do you think? Kind of woohoo? That's the orange one. And then I need another color. We'll go with, ooh, that's going to be not a high contrast color. Let's see, blue. Let's try blue. Oh, my blue box is all over the place. R minus C, again, I need, since this is a single quantity, I need to put it in parentheses, times 1 also equals 8, and that's blue. Okay, so now what? Well, I've got a couple of options. My first option is to say, I don't know that I want to deal with this fraction. So I might want to clear this fraction. So I could multiply everything by 3. But I have another suggestion I'd like to introduce. I would like to suggest that for just this equation, we multiply both sides of the equation by 3/2. So if I multiply 3/2 times, I'm going to move the 2/3 in front, 2/3 times R plus C equals 3/2 times 8. Now, this bottom equation is just r minus c times 1 is r minus c equals 8. What happens up here when I multiply both sides by 3/2? So it's a little fancier. It's a little bit more interesting way of clearing fractions. Not just multiplying by 3, but 3/2. The benefit here is, where's my red pen? When I multiply by 3/2, the 3 cancels and the 2 cancels. And so up on top, I've got just r plus c equals 3/2 times 8. And the bottom equation is r minus c equals 8. Okay, so what's 3/2 times 8? Well, if I make this 8/1, I can see the 2 cancels with the 8 and leaves 4. So then I've got r plus c equals 12, r minus c equals 8. Now, I realize that as we're looking at this, we're like, oh my gosh, there's so much going on. And so I will take us back to, you are allowed to use a brace to keep track of, and I don't know if this helps. If this makes it worse, then don't do it. But if this helps your mind, you can put the brace over on the right, or you could even put it over on the left if you like. I had more room on the right. So to help your brain see that we're blocking this in 2 equations at a time. So now let's look at what we've got. We've got r plus c equals 12. R minus c equals 8. Oh my goodness. What can we do with this? Can we just add them together? That was a lot of work, but once we get to here, if we add them together, 2r equals 20, r equals 10. Okay, and then what does c equal? R plus c is 12. 10 plus c equals 12. C equals 2. So let's look at the original problem. Was that what we were actually looking for? Was it that simple? Calculate the speed of the boat in still water, that's R, along with the speed of the current, that's C. So R was 10. Let's take a look at the chart. R is measured in miles per hour, right? Down here are miles per hour. The current is C miles per hour. Sorry about that. Miles per hour. Miles per hour. And C is 2 miles per hour. Okay. Now I know a lot of people are looking at this going, oh my goodness, how would you ever do this? So since, this is a long video, but it's not impossibly long yet. So let me do this. And I want to introduce you to another version of this, which I will put in the notes. And the other version of this problem is right here. Let me give us some space. So let's just quickly walk through this. I did the same drawing of up and down, and I had R and C. So if the speed of the boat is R and the speed of the current is C, then down the river is R plus C, and up the river is R minus C. Look at the difference that I chose here. Instead of choosing to go with hours, I went ahead with minutes to show you what that would look like. And so I put R plus C and 40 minutes instead of, wait, where's our, so many pages. Instead of what we did just now with 2/3 of an hour and 1 hour, I wrote 40 minutes and 60 minutes. And then, because I didn't have fractions in the same way, the solution looks really different. I had 40 times R plus C equals 8, right? From that, this is, let's see, I think did I use orange on top? What did I use? Orange on top and blue on the bottom. Okay. So orange on top is this guy. So that gives us that equation. And then blue on the bottom gives us that equation. And so instead of clearing fractions, I multiplied out and I got 40r plus 40c equals 8, or 60r minus 60c equals 8. Then I multiplied on top by 3, on the bottom by 2, so I could cancel the c's right here, a plus 120c, a minus 120c. I added, I got 240r. Over here I got 40. And then, then this got exciting because remember when I said there are pluses and minuses, there are advantages and disadvantages. R ends up being 1/6 of a mile per minute. And then I went through and I said, okay, if R is 1/6 of a mile per minute, and then I said we could find, I'm going to write, we need to find C. And then what we discovered, this is too hard. So I was showing that if you plug 1/6 in here, the numbers are just too hard. It's yucky. You're dealing with 6, that's just blah. But over here, if you plug in 1/6, you've already got the 60, which cancels. And then it's a much simpler situation. C is 1/30 miles per minute. And then to convert to miles per hour, multiply by 60. So 1/6 times 60 gives us 10 miles per hour. And 1/30th mile per minute becomes 2 miles per hour. So I will put this into the notes as well. Let me even this out again so you can screen capture it if you want. There we go. So if you want to, this is another way to do it. Okay, we got through. This is one of the hardest ones there is, really and truly. Is this the only way to do this problem? No, I can think of at least 2 other ways to do this problem. I just picked what I thought were the 2 most accessible ways to do it. You can always come to me, come to tutors and say, I see this solution, but I would like to see another. Is there another way you can think to do this? And usually, even if the tutors aren't really sure, they can check with me or you can check with me directly and we can find another way for you to do it. So there are multiple ways to do these problems. We made it. This one was the bear of the problem. The rest of the problems, I think there are 3 more. They are not nearly this difficult. They're geometry problems, I think. Oh no, there are 2 geometry problems and a magician. Woohoo! Ooh, magie. Okay, so I will see you in the very next video. You guys are awesome and amazing. You're making it through. We're gonna have a couple more problems, then we'll be done with word problems. Yay! For a little bit. Okay, math on, guys. Math on.